Hello and welcome to our panel today here at IASDR 2021. My name is Elaine Igoe and I'm chairing this panel discussion. I'm a senior lecturer at the University of Portsmouth and visiting lecturer at the Royal College of Art and a researcher in textile design and design theory. I'd like to welcome our panelists today who are experts on smart textiles, e-textiles and wearable technology. First of all, I'd like to introduce Anne Toomey. Anne Toomey is the head of textiles at the RCA. She has a background in commercial design and over 21 years experience in academia. Toomey has a track record of initiating innovative approaches to cross-disciplinary collaborations between industry and academia. Under her leadership, the Textiles programme established the Soft Systems Research Group, who focus on textiles innovation, incorporating aspects of emerging material science with design to develop novel multisensory textiles that offer new applications and routes to market. She's a principal investigator on project RP37 at the Laboratory for Artificial Intelligence and Design, or AID Lab, at Hong Kong PolyU. Our next panelist is Jeanne Tan, who is the Chief Operating Officer for the Laboratory of Artificial Intelligence and Design at HKPU and Associate Professor of Design at the Institute of Textiles and Clothing. Jeanne's work investigates the interface of design and technology, and she'll be talking more about that in her presentation shortly. Our third panelist is Dr. Elif Ozden-Yenigun, who is Senior Tutor in Textiles at the Royal College of Art in London. She's a materials scientist interested in nano-engineered textiles, smart wearables, and soft sensory systems. She's authored numerous articles and other papers and presentations which have appeared in international conferences, and she's filed international patents and secured research grants of over 1.2 million from research councils. She is also a principal investigator at AID Lab on the project RP25 Intelligent Systems for Innovations at AID Lab. Our fourth panelist is Sara Robertson. She's tutor in research in smart textiles at the Royal College of Art London, leading the soft systems specialism on the MA Textiles programme. She also runs a consultancy in business with her long-standing collaborator Sara Taylor called Sara and Sara Smart Textile Design. They are currently working on research funded by the Connected Innovators programme, exploring the creative use of data for smart textile design. Our fifth panelist is Dr. Gozde Goncu-Berk, who's an assistant professor at University of California, Davis in the USA. She directs her research group under Wearable, focusing on human-centered design of textile-based wearable products for people with special needs. Gozde's research explores the possibilities of electronic textiles and smart clothing, including new material and digital fabrication technologies to facilitate design for a variety of body types, environmental and activity-based contexts. And our final panelist is Rachael Wickenden, who brings over 10 years' experience in multinational textile companies to her role at Nottingham Trent University's Advanced Textile and Clothing Sustainability Research Group. Her research questions the drive towards the seamless integration of electronics into textiles because of the difficulties hybrids present for repair and recycling. I'd just like to introduce some of the main themes of our panel today. However, despite these commercial predictions, emerging research is highlighting the limits and contradictions of growth in commercial applications for smart textiles and materials. The move to more integrated computational components in smart textiles and textile-based wearables have implications for sustainability. Combining electronics and textiles, both relatively short-lived mass consumer goods, will intensify product obsolescence and lead to even shorter life cycles and abandonment of products. Continuing to approach the design of smart textiles and wearables using these existing modes which just prompt consumption will further threaten sustainability. We need alternative design approaches which are critical in questioning and rethinking the current state of play and transitioning to truly smarter avenues for smart textiles and textile-based wearables. So I invite you all to participate in our panel today by adding your questions to the chat box. The IASDR support staff will also be sharing 2 links with you whilst the panelists provide some presentations. The first is a spreadsheet where we'd like to invite you to share your contact details with us so that we can share some of the outcomes of today's panel. And the second link is a Padlet, which you may or may not have used before. And we've posted a series of questions that we'd like you to interact with during the panel discussion today. When you log on to Padlet, you can either post anonymously or log in. Please just click on the small circle with a plus sign in it, and you can add your responses to the questions that we've added there. So I'll now go and invite each of the panelists to share a short presentation with you all, which will then follow with a series of prepared questions, but then we'd love to include some of your questions from the chat box into our final Q&A. Okay, first presentation is from our panelist, Anne Toomey.
Hello, I'm Anne Toomey, Head of Textiles at the Royal College of Art. I'm going to introduce our Soft Systems Research Group and some examples of projects. In organisational management, Checkland's Soft Systems methodology recognises flux as the state of being and cautions against the solidification of parts of that flux as situations, problems, or issues. What does this look like when interpreted through a textile lens? Within the group, we rethink materials and fabrication processes to discover new applications. It is this constant act of decoding and recoding that helps us to think of these new applications as soft textile systems with purpose that range from the functional to the poetic. Rather than classifying our practice through our methods of assembly, such as weave or knit, Soft Systems aims to link together many aspects of textiles, such as materiality, context, and affect in a symbiotic system. Essentially, it is an approach that recognises the complexities of our material world and our relationship with it, and uses this as a platform for exploration and innovation. Established in 2017, we are building a networked community of practitioners, academics, researchers and industry partners who share these interests as we build new knowledge from new ways of thinking through making. With collaborations and partnerships in the UK, Hong Kong, Japan, Istanbul, Eindhoven and California, we look to build this knowledge across cultures and approaches. New types of materials with new characteristics and behaviours offer unprecedented opportunities to rethink textiles. However, the old, the familiar and the known can also yield these opportunities when examined afresh. Textiles is a very broad discipline that touches on almost every part of our lives in some way or another. Our research group, therefore, is not focused solely on cloth and textile products and is characterised by interdisciplinary collaborations. Our group is an open and informal platform for gathering like minds to jointly scope what soft systems means in a truly interdisciplinary context. The following slides are some examples of projects that take this soft systems approach. The first is an example of looking afresh at the old, familiar, and the known. S++ was a collaborative project between RCA Textiles and the design lab at Kyoto's Institute of Technology. And the purpose was to re-engineer traditional chirimen silk and turn the traditional kimono silk into a system-based textile for healthcare applications. Hacking the traditional weave by substituting PTT, a thermoplastic polymer, enabled the creation of a hybrid textile which is hydrophilic and hydrophobic at the same time. And this hybrid textile structure offers new product applications for chirimen silk in healthcare contexts against a background of industry decline and shrinking markets. The project brought together a very complex and multidisciplinary range of collaborators. My next example is Krafttec, and this was a collaborative project between the RCA Textiles and Fashion Programmes and the Institute of Textiles and Clothing at the Hong Kong Polytechnic University. and the aim was to interrogate the crafting of materials associated with wearable technologies. Within the project, we specifically wanted to explore and exploit the characteristics of textile design practice to uncover new constructs for interactive textiles. In developing new thinking through making, we used a mixed approach to construction and material manipulation that included a variety of textile techniques alongside basic electronics. The project uncovered further insights into the value of materials exploration, thinking through making and craft approaches, and how these practices are relevant and contribute within a technological field. This shared experience of thinking through making led to setting a framework for new priorities, summarised in the next slide. This last example brings together even more diverse disciplines to look at how we can develop textiles to contribute to systems in the fourth industrial revolution, and specifically artificial intelligence. Here we see aspects of smart textiles in the central area, bridging a gap between the physical and digital domains. My final slide introduces my latest collaboration with the Hong Kong PolyU under the umbrella of the AI Design Lab. My colleague, Dr. Jeanne Tan, will expand on this exciting new initiative during her presentation. I would like to briefly summarise the project that I'll be leading with the RCA's Head of Fashion, Zoe Broach. Neo-Couture asks if we can rethink the way that we approach innovation in textiles for fashion. Built in the digital realm, using artificial intelligence and positioning nature as our protagonist, we investigate a future materials landscape where the binary zeros and ones meet the genetic code of A, T, G and C. Can the digitised material of Neo-Couture assist and advance the immediate construction systems of 4IR through an exploration of artificial intelligence from a design-led perspective? We create cloth with simultaneous realities in both the digital and physical domains. Will this new way of approaching bespoke fashion enable a new design freedom and a new aesthetic through working through computational materials? Thank you.
Thank you for that presentation, Anne. So please, if you could prepare some questions that you might like to direct towards Anne, that would be great. Our next panelist is Jeanne Tan.
Hi, everyone. I'm Jeanne. I'm very happy to be here to share with you our project on intelligent textiles for well-being that we're conducting here at AID Lab. So at AID Lab, we are one of the 28 research laboratories that's funded by Hong Kong clusters, focusing on research on AI. So this is a strategic collaboration between Hong Kong PolyU and the Royal College of Art. So I welcome everybody to come onto our website to take a look at the interdisciplinary research that we conduct over here. So as we all know, smart textiles and wearables, well, this is such a hot topic right now, and we know that it is an area that concerns a wide range of skills and knowledge. However, conventional education right now is still focusing on being very discipline specific. So everything is considered as a very separate and a very distinct approach. So when we have emerging innovations that require interdisciplinary solutions, we find that it is always or often very difficult to find a common language in between. There's always gaps in between that we seem to be constantly trying to fill. So we can see that as our lives are changing, the evolving needs see that we have a demand for products and services that go beyond just reactive functionality. We are looking for materials that will be able to adapt because that's one constant in life, isn't it? The constant is that we will always constantly have change. So these new products and services require comprehensive systems, and so that we can actually retain the longevity of the product. I think one of the most exciting key areas that we are discussing as a panel is about responsible innovation. And I think for responsible innovation, it should work in line with the product longevity. So at our team here at AIT Lab, and in collaboration with Anne, our team is working on intelligent textiles that has the ability to interpret images and to deliver response without the need for physical interaction. So we are hoping that these materials will be able to anticipate and provide appropriate solutions for the user. So we are going to use these materials in the context of multisensory environments. Predominantly, we are aiming at users with dementia and users with learning disabilities. So just to give a little background about multisensory environments, these multisensory therapy has a positive impact on users. It is a very non-invasive intervention. So, and the multisensory environment is often designed as a space for enjoying sensory experiences and gentle stimulation of sight, touch, taste, smell, and hearing. And it is proven to promote cognitive development, coordination, concentration, and develop or reactivate senses. So in our previous work, we have often relied on textiles that has got integrated sensors. We can touch them and they will have a reaction. In our research, we find that one of the things that we really need is to have a different way of interacting with the textile. So our solution is to use computer vision. So we hope that this is an intuitive process. You can see that we can interact with the textiles by using our finger gestures. So these intelligent textile system is based on computer vision using three main steps. So we capture the image, use computer vision to decipher, and then we provide illumination through our POF textiles. So we use the AI model, tiny computer, and our knowledge in weaving POFs and knitting POFs into textiles to create that visual stimulation. So we hope that our fabrics will have impact on social good, because this will be a contactless, safe, non-invasive sort of sensory rehabilitation. So now to this point, we were talking about having responsible innovation. I think there's a lot of things that we can do for now, but I also think that part of being responsible is also contributing to the future ecosystem. So by bridging disciplines to creatively innovate, we can actually contribute to future ecosystem. We can nurture interdisciplinary approaches, interdisciplinary thinkers, so that we are no longer inhibited by, oh, you are good in science, henceforth you have to do the tech, you're good in arts, you have to do the art and design. No, I think every aspect and perspective is valued, and it is good for all of us to start thinking in a very interdisciplinary way and contribute to our future design talents. So this is my presentation, and let me go to my final slide. So feel free to come and take a look at my website for my research. And we have just had a new publication on intelligent textiles, and this is the link for it. So thank you very much.
Thank you, Jeanne. And our next panelist is Elif, Ozden-Yenigun.
Hello, everyone. It's an honor to be a part of this amazing panel and be sitting among these creative voices. Thank you, Elaine, for the invitation and organizing this panel discussion. In the panel today, we will discuss the future of smart textile design and wearable technologies. As a material scientist, I will advocate for the researchers working in the materials world. I am Dr. Elif Ozden-Yenigun, a senior tutor in textiles at Royal College of Art, and also one of the investigators in the innovation design project funded by AID Lab. In my research, spanning different technical applications, I often use textile making processes, sometimes for constructing the fabric or yarn, or sometimes for adding new functionalities to the tangible material systems. I'm also co-founder of a company that offers material solutions for the aerospace, healthcare, and automotive industry. So, about my research. Quoting famous physicist Richard Feynman and his famous lecture, "There is plenty of room at the bottom," Feynman considered the possibilities of direct manipulation of individual atoms as a more powerful form of synthetic chemistry than those used at the time, in 1980s. It went largely unnoticed and didn't inspire the conceptual beginnings of the field of nanotechnology. But we live in a different world now, and we understand how valuable it is to control a single atom and achieve hard-to-combine properties, including strong but light, electrical insulator but thermal conductive. So in my research, we start to control in the subatomic layer and translate into different assemblies and forms from nano to microscale. Embracing computational and experimental methods leads a precise control at the interface and then dominates the whole structure. I am fascinated by quantum and molecular computing and what it offers. I was introduced to modeling in my PhD study. Since then, I use this very powerful and complementary tool because it opens a scale unattainable for humans, at least by experimental run and error methodologies. So we manipulate simple intermolecular interactions, and in an example, we created super hydrophobic surfaces with dual scale roughness, similar to the lotus flower, without using any complex coating or processes. In another work, this is an example, we understood how each carbon nanoparticle decreases the cross-linking density in composites without sacrificing mechanical performance. On that note, the advancement in computational resources take this complex modeling text to a new level. We discover new materials without putting in material efforts, AI algorithms and machine learning also complementing them. For the last 3 years, wearable communication and bringing sustainable material solutions to E-Textiles have been the focus of my research. We think we are heading to a more soft future of wearable electronic and electronics in general. So we see the future where we do not have to use any rigid components, including circuitry boards, wires, LEDs, and the textile itself can offer all these different functions. European Chemical Society, when celebrating the 150th anniversary of periodic table, they revised the periodic table based on the resources that we have left in Earth and highlighted some elements such as gold, silver, and many more used in mobile phones, transistors, and touchscreens that have serious threat in the next 100 years. Considering the high demand, the scientists expect it will be sooner than that. So wearable technologies and E-textile are also heavily relying on the same metal use. So now we have to question our material conscious. I'm just gonna play this video very quickly. Towards sustainable E-textiles, we use carbon as our main research material. We use traditional textile techniques and fabricating graphene-based wearable antenna system that respond to a broad range in wireless communication. You can see how soft they are. No ground plate, no wiring. You can wash, dry clean, or iron. They are durable and also do not cause any contamination in the recycling streams. We recently actually initiated a project in AID Lab that we call Sensory Materials Library, a database that you can use the sensing and perceptional tool to capture some features, countable or uncountable. The psychophysics and the phenomenology research suggests that can be replicated digitally to produce a sensory experience. So very shortly, we will share a call to recruit postdoctoral researchers and research assistants. So we are also looking forward to receive some resumes from Hong Kong. We are grateful, we are always grateful for our research funders and also AID lab support on this new chapter. And thank you all for listening.
Thank you, Elif. Our next panelist is Sara Robertson. Please, attendees, we'd love it for you to interact with some of the questions we've added to the Padlet, and do add your questions in the chat box too.
Morning or afternoon. I'm Sara Robertson, and I'm taking you back in time a little bit with my research. The use of smart materials for textiles offer the opportunity to design and draw parallels between nature and our natural environment for use within our everyday surroundings. They also offer a vehicle to design with natural phenomenon within our environments, such as changes in temperature, light, and humidity, for example. Examples are shown here of designers and researchers' work who have explored colour change through the use of technology, using technology not as an integrated aspect of the work, but as a tool to view the full potential of these reversible colours. Maggie Orth, one of the pioneers of bringing together textiles and electronics, described her approach to her materials as working in textiles allowed me to physically transform technology from hard, functional, mass-produced, and progress-orientated into something soft, sensual, and intimate. Electronic textiles allowed me to handcraft my computational medium, creating a circuit and its electrical properties like resistance, simultaneously with aesthetic design. Handcrafting computational media aligns my work with arts and crafts practices, which seek a deep understanding of the medium through physical process. The properties of smart materials captured my imagination in their ability to change colour in response to temperature and visualise touch. 15 years ago, when I started my PhD working with smart materials for textiles, the work was led by curiosity. How can these colours be applied to textiles? How could colour play, the spectrum, be extended? And how could I observe and record these colour changes for a design audience? These questions started a journey in a similar way, which Maggie Orth describes, with electronics and computing. The circuitry systems I developed were used as a tool to observe and measure colour change, and were not integrated in the textile itself. Ultimately, perhaps this work with colour could inspire new thinking around colour systems and colour design. At this time, collaboration and work with other disciplines started for me. I needed support from industry, expertise and help from electronics and computing. I contacted and approached many different companies and researchers at different institutions. I ended up receiving support from unexpected places, from shipbuilders to Oxford researchers working on hydrogen fuel cells. Collaboration and working across sectors and disciplines has continued within my research and has been vital to understanding this area of design. Alongside my academic role, I now run a small research-led business with my long-term collaborator, Sara Taylor. Both our work was rooted in the area of smart textiles through a craft and materials-led approach. And now we use this way of thinking through smart textiles as a way of exploring soft materials with light, electronics, computing, digital technologies, and more recently, data. Our work developing light-emitting lace with MYB textiles integrates polymer optical fiber into woven madras lace structure. The relationship between the structure of the weave and the optical fiber allows the light to be released, creating shadow and light play across the cloth. However, this integration has made us question our work at every stage, and equally the use of polymer fiber itself. The cloth was designed to be finished loom state. It comes off the loom in its final form with no further finishing required. The cloth develops a patina over time. The light transmission changes over time through use. We designed a selvage edge to be able to extract the optical fibers easily from the cloth and design a modular lighting system which is fully detachable from the fabric. This goes some way to addressing designing smarter, but doesn't go far enough. We are now moving away, or further away, from development of smart textiles, but exploring creative process that's used within smart textile design to unpick and question the differences and areas that we could design smarter and in more meaningful ways. Working and researching in this area for a long period of our careers, we have been challenged to change our practice, and we are just starting to approach our work in these new ways. We don't have great revelations at the moment, but we are on a new path. Thank you. I'll just stop sharing. My cursor's disappeared. Could someone stop sharing my screen for me, Elaine?
I can't stop sharing your screen.
Oh, I think I've done it. Sorry. My cursor.
Sara. Okay, we have two panelists to share their presentations remaining. The next is Gozde.
Hello, everyone. I'm Gozde Goncu-Berk from UC Davis Department of Design. I'll be sharing my presentation, which is recorded for the sake of timekeeping. And I'm going to move us to the product level from the materials. Hello, everyone. Today, I will talk about sustainability of wearable technologies at the product level, mostly focusing on smart clothing. The rapid temporal cycles of current technology embedded into wearable products have profound environmental impacts when doubled with the conspicuous consumption and fashion. Parallel to this, research showed that 1 in 10 American adults own some form of wearable technology device, but half of them abandon use of these products within the first 6 months. Products' environmental impact can be eliminated through better and intentional design. Smart clothing holds the potential to offer a more sustainable option to traditional clothing if they offer better value for the end user and therefore lead to longer user product attachment. I will discuss opportunities and hurdles for increased user product attachment for smart clothing, combining Norman's emotional design and Lam and Callow's functional, expressive, and aesthetic clothing design frameworks. At the aesthetic level, I will focus on possibilities of transformable appearances in smart clothing. At the functional level, I will discuss fit, comfort, mobility, and care of smart clothing as they relate to effectiveness of use. And at the expressive or reflective level, I will touch on the communicative and symbolic aspects of smart clothing. Smart clothing could offer possibilities of updating their appearance through change in color, texture, pattern, and even form, reducing the need to constantly purchase a new and up-to-date item. An example of such technology is the electronic ink microcapsules laminated onto a film, which then can be applied to any surface, including textiles. The e-ink technology offers an energy-efficient alternative to LCD screen displays that rely on significantly high battery power. Examples of e-ink displays in which wearers can upload, change, and customize design and patterns via a mobile app appeared in watches, t-shirts, and in shoes already. Shape memory materials have the ability to remember and return to a previous form after being subject to thermal stimuli. Researchers experimented with shape memory alloys, origami folding, or smocking and pleating techniques to develop smart clothing with controllable form change. Individuals could abandon using smart clothing due to factors that relate to the behavioral level of design. In addition to the care and maintenance activities inherent to traditional textiles and clothing, new maintenance and care activities and skills are required for smart clothing, such as charging, accessing and/or storing data collected, specialized laundry requirements like removing hardware component or hand washing. For example, Levi's and Google's collaborative smart jacket, which comes with an E-Textile-based interface where one can change a song or pick up a phone, requires removing of the Krafttec hardware, and then the jacket can only stand up to 10 washes before it loses its interactive abilities. Comfort and fit are other important factors that affect long-term user product attachment. Many smart clothing require close contact with skin in order to collect data, which result in tighter, compression type of fit that may impede with comfort and body image for different personal physiques. Sizes, locations, and numbers of hardware components attached to clothing may also hinder comfort parameters related to mobility. The use of smart clothing may require building new mental models. In other words, new thought processes about how traditional textiles and clothing function in ways that may affect the ease of use. Certain smart clothing may need different ways of donning or doffing, or other wearing requirements. For example, smart shorts available in the market that track muscle activation from glutes would require direct skin contact and therefore wearing no underwear. Or smart socks would require wearing secondary hard components around ankles. Wearable products serve reflective level of design in three ways: by optimizing of the self through enhancing and augmenting the body, by formation of larger and connected communities around their function, and by infusing the owner with feelings of singularity. Some wearable technology that especially tracks human conditions require the garment to be customized to the wearer and provide singularity in terms of the functions. For example, Natty Axe yoga pants integrated sensors and haptic feedback to help to improve yoga poses and provide a personalized feedback. In this context, machine learning technology, or the idea that systems can learn from data and make decisions without human intervention, also holds high potential for the customization of smart clothing. Although there are limited numbers of smart clothing that make it to the market, they are regarded as the future of wearable technology, overshadowing smart accessories. However, it still is unknown what happens if smart clothing becomes the norm, replacing traditional clothing. I just shared on the background a snippet of my research on smart clothing. Please feel free to reach out to me via email and check my work at my website. Thank you for listening.
Thank you so much, Gozde. And our final panelist is Rachael Wickenden.
Okay, so my name is Dr. Rachael Wickenden. I work for Nottingham Trent University in their Fashion and Textiles Research Centre, which specifically comprises also the Clothing Sustainability Research Group and Advanced Textiles Research Group. So I straddle very much these questions of the impact of wearable technology and e-textiles, but also their development. So my PhD research as a textile designer, we've often been used to focusing on the materials themselves, and this is in contrast with a product design approach where it might be more evident straight away the purpose for which you're designing. This new approach, though, with e-textiles or smart materials requires a different kind of thinking where the materials are both an emerging technology and therefore are ambiguous and uncertain, unlike traditional textiles, where we've been aware of the role they have in our lives, clothing, and in our interior environments, whose purpose is to provide comfort, to provide warmth and protection. E-textiles, on the other hand, don't have this same defined roles. We're still working on what their purpose might be. And the question I asked in my PhD was, does the positive value of an e-textile's purpose outweigh its possible negative environmental and social impact? An example of this thinking, we have many e-textiles that are being used for the simple purpose of Christmas jumpers, providing temporary novelty as their purpose. But it is the question we need to ask, is this really of sufficient value? And we can think about this in terms of Tonkinwei's idea, where he talked about the concept of use value, which is this relationship between something's purpose and its value. So value in this sense being an ethical question rather than a monetary sum. And as has been mentioned, e-textiles were largely started development in the late 1990s with the likes of MIT and Georgia Tech, in part a reaction to research at, for example, the MIT Borg Lab, where these rigid objects were being worn, and researchers like Margaret Orth saw the possibility for textiles to be an alternative. Thinking about levels of integration with e-textiles, there are various possibilities. It could be that the electronics are put in at the level of yarn manufacturing, which is something that the Advanced Textiles Research Group is pursuing. It could be at fabric level, a surface embellishment, or during product assembly. And the tendency has been to assume that a greater level of integration, more integration, is better for the user. But this is actually something we should maybe question. So thinking about two products that are for us as the same purpose, which is to give a new sensory experience of sound to people that are deaf or those that just wish to experience sound in a different way. Both the SoundShirt and Neosensory's wristband serve this purpose. The SoundShirt, which won Time Magazine's Innovations of 2020 award, uses vibration motors in the garment itself. Neosensory, which was a company started by Stanford University Professor Dr. David Eagleman, uses similarly vibration motors. But although the team originally investigated clothing and wearables as their application, it got transformed into a wristband. And what this allows is that without the problems of fit or questions of hygiene, the Neosensory wristband is also available via a subscription model, which allows people also to use it in the treatment of tinnitus. So thinking about systems in a different way and what smart textiles could be, Kirsty Cusk's research is an example where the technology is no longer integrated in the textile at all. So in terms of integration, what we're actually talking about is integration of functionality so that it provides together this system a seamless experience. So this thinking of systems, it might be that we start looking at wearable constellations, which were one of the proposals of the electric corset project that happened at NTU. Or thinking of Lucy Sushman, that we think about hybrid systems composed of heterogeneous devices. So it is this proposal of soft systems that explore a broader approach to electronic textiles, thinking about systems, how they fit into their wider environment, that may be the route forward. Thank you.
Wonderful. Thank you to all the panelists for such amazing and varied presentations here, which are touching on this notion of systems and how it's an alternative approach to understanding smart textiles, e-textiles and wearables is this systematic approach. We're touching on craft, design and material science at a molecular level. So we have a fantastic range of expertise here. So please do add your questions to the chat box. We're going to start the Q&A session now with our first question from the audience member, Marcel Helmer. Marcel asks, current projects that take part in both worlds, textiles and electronics, often seem to have the issue that they have the feeling of being either one, an electrics or a textiles project, with the other one attached to it. And this kind of leads on very nicely from Rachael's presentation. And obviously this can lead to it sometimes being dismissed by kind of either side as just being a mere attachment to either which way that it's been considered. Do you think this issue is entirely based on the lack of collaboration? So if any of you panelists have lots of experience on collaboration with scientists and engineers, do you think there's ways that these collaborations could be more effective? Any comments? Who would like to jump in on that one? And Toomey.
I'm going to start by actually referencing Jeanne here and some of the things that she brought into her presentation, where she was talking about the way that all the disciplines are taught in quite a siloed way when we're younger, and that if we go down that route, then we take those very with quite sort of borders around them, and they've got parameters around them. We take those disciplines to a collective space where we collaborate. And I think that's one of the issues, is that we take our things. Having said that, I would also propose a sort of counter position where if you're too much of a generalist and you don't have the specialist skills to bring to a collaboration, then that can also be problematic. So I'm afraid I don't have a problem. I don't have an answer for Marcel there, but I do think that there's something about the separation of the different disciplines as we learn and acquire our skills and knowledge.
Sara, I wonder if you could add something to this. You mentioned the way that you'd worked with people from a vast range of disciplinary areas. I wonder if you have a perspective you could add.
I suppose, like Anne, I don't have a really clear answer for Marcel, but I think from my experience of working with different disciplines and also different sectors in industry, you have to have a kind of shared goal in a way. So the collaboration or the learning has to work both ways. And I think if sometimes or often it can be a case of gaining something for someone else's benefit, and that doesn't always then result in the best possible design or the best possible outcome to a collaboration. So I feel like you have to be able to work together from the beginning and develop those ideas together. Otherwise, you end up with something where you don't have enough quality time to develop an actual outcome that's realistic and shared between the stakeholders, really. But it's difficult to do.
Thank you. Elif, I was going to come to you because you obviously are in a very interesting position in your role at the Royal College of Art, being a material scientist within the design department. So you're kind of working in this collaborative way across engineering and design on a day-to-day basis.
I mean, I just want to acknowledge one thing, actually. There's a mismatch in mediums, like the material mediums. Like, so an electronic engineer is, who is comfortable with, computer interfaces, this boardings, this electronic circuits, but, not very comfortable working with yarns. And in constructing the textiles, and it's the same for like a textile design. I think this is all how we train. In a way, maybe we should bring this collaboration part back into the education, either in the undergraduate level, maybe in the high school level, because I think we started a bit late sometimes, and that's why I agree with the comments. So that's why it's like it looks like a textile student doing an electronic project or electronic student doing a textile project.
And Jeanne?
Yes, building on what Elif just mentioned, I'd like to bring up a project that Anne and I have been working on in Hong Kong, which is teaching STEM education, exploring the use of interactive textiles for STEM education in secondary schools in Hong Kong. And we have reached over 500 students, and we found that this is really an area that we should start planting seeds, because at that level, they are still being taught that, oh, you are good in the arts, so you should just stay in the arts, or you're good in technology, then just go to the lab. So we find that when we start using the medium of textiles, they find that, hey, this is something that's so applicable. And for students who might be interested in fashion, they think, hey, does that mean that I have a role in technology too? So this is not an exclusive area only for the scientists. This is something that everybody can participate in. So I think it is also just going backwards and then starting right from the very beginning, helping kids understand that there's no boundaries in the way that you think or consider things. You can do it from many different perspectives, and they are all valued. And also about having research students who straddle both electronics and textiles. I'm very lucky. I have one student who have a double degree in electronics and fashion design, but these are so few and rare, and unfortunately, they have to graduate sometime. So they will have to leave me at one point. So I'm looking towards finding more of these little treasures everywhere. So if anybody knows anyone, please give me a heads up.
So we have, educators who, the architects of this new way of collaborating, with across disciplines, but also developing a more holistic and collaborative knowledge. Rachael, I wanted to come to you because I know that your PhD research really considered these kind of types of knowledges and how they come together.
Yeah. One thing that I noticed running the projects that I was doing was that all involved need to be prepared for a period of the project where they maybe don't feel as useful. And it's finding a way to make that time where it's maybe not directly their expertise that are coming to play in the project, but allow them to have a voice in that whole process. But it is very difficult for people, because we are so trained in different disciplines, to see that time where it's sort of somebody else's expertise that are most coming to the fore, how they can have a role and have a voice in that part of the process. So I think certainly it's something that NTU is aiming for, is to bring more interdisciplinary collaboration. And there's now in both first and second year across the entire school, they have to work on interdisciplinary projects. So certainly this training at undergraduate level hopefully is something that could start to influence the development of this kind of project, but also in other areas of interdisciplinary collaboration.
Thank you. Gozde, you wanted to add to the point.
Yeah, I just would like to follow up on what almost everybody said on working across disciplines. As someone who sort of has not research, but also background in both product design and then later textile and clothing design, I just know the value of it. And in my current department, we are such an interdisciplinary department that our students do not take a straightforward path and specialize in one aspect of design. Rather, they take courses across design disciplines. And as Jeanne was saying, I would get students who'd have a lot of coding or electronics or maybe graphic design experience, and maybe some with some more pattern making experience. And during my research, I collaborate a lot with biomedical engineers and UC Davis Health. And it's almost like, managing this orchestra of different skills and bringing them to the project at the required time, and bringing them to discussion and collaboration at the required time, rather than keeping the whole team together from the beginning to the end, seems to be working best for me. And then the other thing is almost like never giving up, because it takes time to build that language, to build that communication, even to understand one another when you're working with a professor. Let's say in computer science or electrical engineering, it takes at least a few months even just to understand what each one of you is saying.
I wonder if there's something in that notion of understanding them systems as well. When you find a like-minded person who understands, the bigger context for the work and how the different knowledges and technologies and skills and materials fit together to influence, as Jeanne mentioned in her presentation, a social impact, a personal behavioral impact. And it's finding those like-minded people, whichever discipline they're from, and like you say, working with them at the right time so that their skills are kind of, utilized at their kind of maximum potential. Thank you for your responses on that question. I'd like to kind of draw out the issues of sustainability that I think particularly Elif mentioned in her presentation, but was touched on by all of you. I wonder, Elif, if you could expand on the kind of emerging issues in the field of smart textiles and textiles-based wearables in regards to sustainability.
From the materials perspective, I think the urgency is to simplify material systems. Like on research papers, we see this outstanding performance of very, very complicated material systems. So I don't think that we are that resourceful. I mean, maybe today, but not tomorrow. So, the E-Textiles are now classified as these monstrous hybrids. So we don't know how to sort them. I think another thing is energy is a big issue everywhere in these electric cars and smart wearables. I think we should also question the battery systems that we have, and like the mobility or the technology in motion. Like whether we need to be that connected, whether we need to gather this data, and do we need this type of components like. Sorry, my confirmation. Sorry to take a part. But yeah, I think overall it's just the key point is I think from now on we need to think more careful about simplifying our material choices, including E-Textiles.
Thank you, Elif. Obviously, as you said, that's the perspective from the materials science point of view. I'm going to go to Gozde now, because obviously you're presenting it from the product point of view.
Yeah, thank you, Elaine. I think at the product level, as I emphasized in my presentation, thinking about the whole life cycle of the product and thinking about how users interact with smart clothing or wearable technology is very important for longevity and limiting the abandonment of products. But also going back to the product level, I see some really exciting research on really new materials and realms, on things like biomaterials, kombucha textiles, or mycelium leather, and ways to integrate conductivity into those biodegradable materials, and even growing living sensors and actuators seems to be like a very emerging and exciting research topic that could benefit sustainability of E-Textiles. And I'm also personally really happy that this topic is discussed. 5 years ago, it was on almost nobody's agenda. We were all very excited about the possibility of creating these textiles that could sense things or that would light up. But now we started thinking the moment we add this conductivity to, let's say, wool textile, we are, disrupting all of its biodegradability or recyclability. So all of these discussions are, I think, very valuable as more of these products are becoming mainstream and going into the market.
Yeah, I mean, you mentioned there about recyclability, and I think both, from Sara and Anne's presentations. Sara, you mentioned about smart textiles, but without any integrated technology within it. And you mentioned about the innate kind of qualities of the Kiraman silk and its natural kind of healing ability. So I wonder if you might add a little bit to kind of to what Gozde was just saying.
I mean, some of the work that we've been doing has been really about, so some of it has been about no integration, but equally some of our work has been about integrating materials into textile structures and mixing materials. So with polymer optical fibers, they're actually woven into a cloth. So they are then part of that product and need to be thought of as part of the life cycle and what happens to them at the end. And PMMA are notoriously difficult to actually recycle. They can be recycled, but finding out how and where and what the possibilities of recycling a PMMA fiber are is really difficult. So for us, we've actually decided that we're not going to use optical fiber anymore within our work. So that's quite an extreme decision for us, considering how much time we've invested. But it doesn't mean that we might not come back to using it. It just means that at the moment we have to find different ways of sort of questioning the use of that material and potentially alternatives to that material, and think of new ways of approaching the materiality of our work.
Yeah, I'd like to just come in and add on that. I think, number one, Sara, you're really brave to be doing that, and I really applaud you. So fantastic. I think it's brilliant. I think, in terms of the Kiraman silk and what we learned through that was that there's so much that is encompassed in even a simple piece of textile that we don't really fully understand. It's sort of, once it's manifested in a product, we tend to understand it from a product point of view and maybe forget about its component parts. And so I always talk about the kind of the decoding, and I think Sara mentioned it's the unpicking of of what something is. And when we look at Elif's work that goes right down to the length scales, and you can then rebuild things and re-look at it in different ways. And I'd just point to one of my heroes, which is Fiorenzo Omanetto's work with silk, and what he's done with silk, completely reinventing its manifestations, its topologies, and becoming incredibly sophisticated. Well, always was sophisticated, but uncovering all of these incredible qualities within it. So I think that we don't necessarily need to look to new stuff to find that, and if we look at Elif's work, that's looking at carbon, so we can look at the things that we think we know and actually find an awful lot more about it. Thank you.
It is rethinking that notion of smartness, isn't it, at a kind of much more fundamental level. Obviously using the incredible technology that's available, as we're seeing with the work at AID Lab, but also, those incredible qualities that we find within fibre and at the molecular level as well, which is fantastic. Okay, to sort of finish off this panel discussion, we had a great question come in from Lionel Wong. I think Jeanne would be a great person to speak to this question. So instead of thinking about electronics and programming coming from distinct roots, do we have any insights about how we can develop a mindset about electronics and programming from a textile or fashion point of view, so that we can unify branches philosophically? How will circuits be like when reimagined by a designer?
Well, this is a really, really tough question. And thank you so much for this question, Lionel, because I think I think philosophically we could always have some unity, but practically, like, the actual making of things, sometimes it's just really difficult. For example, a circuit board is not designed to be integrated into a textile. So that's why, for example, Cute Circuit has done work to make sure that it integrates better. They make sure that it has got the aesthetics, etc. But it takes years and years and years of research and development. Again, we go back to having the luxury of time, where we will be able to make things that is implicit in my so-called discipline. Here I am trying to say that we should be interdisciplinary, but I'm still thinking, there's a lot of things that has been ingrained in the way that I think, that I think is so obvious to everybody else. But if I have a new team member coming in from coding, or maybe I have a new team member that comes in from a psychology background that's helping me develop products for multisensory environments, we will actually have to invest time to make our implicit thinking explicit. So I think there is a lot of work in front of us, but I think the best thing about having our cohort, like having a group of us sitting here discussing about this, means that we are already on the path to this. So thank you.
Thank you, Jeanne. I'm going to bring in Rachael Wickenden next on this.
It's an interesting question. I know that my experience at NTU, a little bit thinking back to the sustainability question, there is a certain resistance among some of the textile and fashion team to want to work with E-Textiles. I feel like they have a greater level of concern about the integration of electronics, or a rejection of them in terms of it feeling like a domain that's geeky, not cool, not interesting. So that idea of bringing it together and thinking about it in a different way would be interesting. In my own experience, there's probably a need for more openness for that kind of crossing to occur. And returning to what Sara was talking about, that ability to pivot and be able to say that the direction that I've been going in isn't necessarily right is not easy for researchers. It is incredibly brave what Sara's done, and I think we probably need more of that. But I do understand that it's very difficult in an academic environment. A lot of careers have been built on following particular paths of ways of integrating electronics into textiles. So the kind of new thinking that Lionel's talking about, it requires quite a shift in what has been going on, and that is a challenge and requires bravery from within the field.
I'm going to turn to Gozde in a minute, but I wonder also whether, in response to Lionel's question, that the problem we have with recyclability, and one of the questions on the Padlet which we added was about kind of, are there any facilities and services to help us think about sorting and recycling and actually having a designer's point of view on the way that kind of circuits are incorporated, could actually much earlier in the kind of chain of design and engineering actually design out those problems perhaps. But I'll pass over to Gozde now, who I think's got an example to give on this.
This is a great question again, Lionel. And I'd like to give a very straightforward example of how I do circuits, how I integrate circuits in my work. So it takes a lot of experimenting with prototyping and manufacturing technologies. I embroider my circuits, for example. So it takes a lot of trial and error to feed the conductive thread and to be able to embroider the transmission lines on a textile surface. Another way I explore this is through 3D printing. Instead of, printing 3D objects, what I try to do is I try to directly print on the fabric using conductive filaments. This way I can create the circuits directly on the fabric, and I can also create interconnects where I can just snap on an LED or a battery. So I would say it's very experimental, based on trial and error to find these new ways of creating soft circuits based on my experience. Thank you.
Thank you very much, Gozde. We've come to the end of our time. It feels like we've just begun, but thank you to all the panelists for sharing their insight and their incredible work, and the bravery that some of the panelists are already taking in terms of educating the new designers and makers of the future, but also making big changes in their own practice to lead by example. So thank you very much. Please do join the mailing list on the spreadsheet that's been shared with you in the chat box. We'd love to keep in contact with you. So thank you very much.